Hi viewers, in this lecture we will study about the codes which is related to the driving axles of a locomotives. What is a code? Code is a symbolic or alphabetic representation which can describe everything about that particular things. We have studied about registers. The code is very much important for interplace understanding. That means if the code for a particular thing is universally accepted, then instead of naming that individual thing, if you name like a code, every part of world they can understand. Likewise, this is a symbol of diode. That means symbol is also a code. Yes or no? So if you ask a person what is a diode, they may not be understand. But if you show this symbol, every part of the world, if they know about these semiconductor things, they will easily understand this is nothing but a diode, right? So coding is very important, and coding in locomotive also take a vital role, as because the engineer which is employed to repair the train, they can understand what kind of fuel should I take to the remote station where the locomotive is getting breakdown. Okay, let me ask you, you have studied about the resistor. So this is a component which actually used to slow down the flow of current. And in these resistors, we are having band of colors. So these band of colors, which is in left side, they actually constitute the rating. The rating of resistor can be understood or can be found. And the last one is nothing but the tolerance. Okay, the tolerance is nothing but how more or less accurate this resistor value. Okay, if this is the rating of nameplate rating, actual value it will not be equal to this, but actual value may be vary with this tolerance. For example, it was written that 100 ohm and tolerance is nothing but plus minus 5%. That means this actual value, the actual resistance of this resistor may vary from 95 ohm to 105 ohm. Many times I told about driving axle. Driving axles are nothing but the axle which is actually coupled to the motor. Let me take a beautiful example of a cycle, because you know everything about cycle. And you know that the front wheel is a dummy wheel, because your pedal is here and the pedal is connected through a chain to the back wheel. That means the back wheel is the driving wheel. Okay, according to your foot pedal, as you make speed up or speed down, the back wheel actually drive the cycle, and front wheel is the wheel just to hold the cycle and to change the direction. So the back wheel is nothing but the driving wheel, and the front wheel is called dummy wheel. Okay, this is important. That means dummy, you can say dummy wheel. If it is dummy, then why should I use it? No, you have to use the dummy wheel, but the name is dummy because it was not connected to the motor. It was just connected to the cycle. Okay. Likewise, whenever we are going to study about the locomotive, in the locomotive we are having many numbers of wheels. Okay, I will tell you why we are going for many numbers of wheels. That is also important. So among all those wheels, every wheel or every pair of wheel will never be connected to the motor, but some wheels are connected to the motor and remaining will not be connected to the motor. That is why we cannot say every motors or every wheels are driving wheel, but some motors or some wheels are dummy wheels. So if you define the codes are symbolic or alphabetic representation of particular things which can be understood or can be accepted by every part of the world. The study of code for driving axle of train is also important for the engineers who actually employed to repair the train for remote breakdown. The second thing, if you know about the course of the train, you can able to guess or you can able to calculate how much weight should you apply to the train without making it damage. So as we know that my train is actually running over rail. So this is my rail. So this is my train. My train is running over rail, and the train or locomotive is actually mounted over wheels and axles. So the weight which can be applied over the train, that can be depend upon the track condition, this wheel, bearing, and also the axle condition. So we can say applying weight first, track condition. Okay, track condition means if the track is too old, it cannot take more load than that of a track which is new one. So the application of weight over the train is depend upon the track condition. Second thing, it depend upon the bearing. So bearing is a mechanical arrangement which can connect a steady structure with a moving structure. Third, the weight also depend upon the ability of axle or strength of axle. What is axle? Consider this is my wheel, this is another wheel, and these two wheels are connected using an axle. So this is my axle. So these are three important things by which the application of weight depends. So this is nothing but a bearing. So this bearing actually used in ceiling fan or table fan. So this bearing consists of an outer ring and one inner ring. So two rings are there, and those two rings are connected using the balls arrangement. Inside you can see these are balls. And if you want to rotate one ring by making steady another ring, this is possible because you can see this inside is rotating and the outer side is steady. The rotation can be made using the balls arrangement. We have to apply some grease here so to make it frictionless. That means if you hold this and you rotate this, it can rotate, right? So this is called a bearing, and here inside we are connected the axles. So axles are connected like this, and the wheels are over this. So actually if my axle is steady, if you try to rotate the wheel can be rotated easily by making the axle steady. So this is nothing but a mechanical arrangement which actually connected a steady part with a moving part. See, the right hand finger is steady finger, the left hand finger is rotating finger, and this is the mechanical arrangement we can make it possible. So if I take two bearings, and I put one axle in between these two, if I apply weight over here, so you can see if I increase my weight, you'll see my axle is getting bent. Yes or no? If I increase the weight, my axle is going to bend. After some times, this axle may get damaged. So if I want to increase the weight of the locomotive, then I have to increase the number of axle. I designed something for you. See, let's consider this is my locomotive, and these are a pair of wheels. Okay, and these are axles. Okay, it is actually running over a track. So if I increase the weight of this train, it actually, what happened? This weight have to take by this axle first. That weight also taken by this ball bearing arrangement. And the third thing, the condition of track also depend to take the weight of this wheel. So this is very important thing in rotating part arrangement. Let us consider a locomotive which is over two axle. That means four individual wheels. One axle capacity is 1 ton. 1 ton per axle. So in this structure we have two axle. That means 2 times of 1 ton. So we'll get 2 ton total capacity. That means this structure can bear a maximum of 2 ton weight, right? If you want to increase the weight of this locomotive, that means let us consider I want to make it 3 ton. What should I do? Because if you increase the weight of this locomotive below 2 ton, these two axle will not take the strength. So we have to insert one more axle, that means one more pair of wheels. So the number of axle depend upon the weight applied over the train. The number of axle is nothing but the ratio of weight of locomotive divided by permissible weight per axle. This is important formula, you have to remember this. Let us study about the coding of driving axle, a locomotive axle. So you have to remember some rules. The first one is, if there are two driving axle, it will represent as B, capital B. If there are three driving axle, it will represent as capital C. Driving axle means the axle which are connected to the motors. Okay. And likewise, if I go for four driving axle, so for two driving axle it is B. If I go for four driving axle, it will be B-B. If you go for six driving axle, it will be like C-C. Right? One C stands for three driving axle and the second C stands for another three driving axle. Okay. If you go for five driving axle, it will be B-C or C-B. Okay. B stands for two axle, C stands for three axle, so 3 plus 2 is 5, and similarly it happened here. So these codes are actually for driving axle only. Okay. And the driving axle are represented by solid structure, a solid circle. Okay. And the dummy axle is represented by dotted circle. Okay, it's clear now? Very good. Next point, if each axle driven by separate motor if each axle is driven by a separate motor, then we use subscript O. Subscript O is used. Right? So I'll explain this thing with an example. 7 point, if axles are driven by group and the group is driven by single motor, then only capital letter used. right? So you can see single axle drive. So we have two wheels and one motor is coupled to drive this axle. That is called single axle. And group means, let us consider this is a pair of axle, this is a pair of wheel, this is another pair of wheel, and this is third pair of wheel, and three pair of wheels or three axle are connected to a single motor. That means you can see motor is connected to all the wheels. That means all are driving axle, but they are worked in group. This is single, this is group, right? For single, we used a subscript O. For group, we do not use any subscript. Simple the letter as it is. And I told about driving axles are represented by solid circle and dummy axle are represented by dotted circle. Okay, let me take some example to explain you better. In this example, it is very clear that this is the side view of a train or locomotive, and we have seen from this side I can see there are 4 wheels, and the other side I am having another 4 wheels. So total 8 numbers of wheels which are mounted over 4 axles, right? And we can see there are no connection between the wheels. And we can see all the wheels are solid wheels. The solid circle represent it must be driving axle. As I told you, 2 driving axle are represented by capital B, and another 2 driving axle must be represented by another B with a hyphen in between these two. Clear? And also in 6th rule, I told you if each driving axle are actually driven by individual motor, then subscript O is used. So here there is no connection. That means it is not a group, rather it is a individual drive. So we have to write subscript O here. Okay, that means this picture's coding representation is B0 hyphen B0. Okay, let me consider another example. So we have a dotted circle here and 3 solid here and 2 dotted here. Okay. Always it is a best practice to code from left to right. Okay. So you can code it from any side, no problem. But it is a best practice to code from left to right. Okay. You can see this is dotted, this is solid, this is solid, this is solid, these two are dotted, and there are no connection between the wheels. So the first wheel is nothing but a dummy wheels. Okay. So you can write 1. Okay. So 1 dummy axle means 1. Then hyphen. You can see 3 solid axle and 3 solid wheels. That means 3 individual drive. It is C. If it is C, C means all are individual. We have to use subscript as O. So C0. And hyphen again. And we have 2 dummy axle. So write 2 here. Clear? Again I am taking one more example. So this is my locomotive. So these are 3 solid axle and these are another 3 solid axle which are connected through a solid line. Okay, that means if this wheel rotate, this actually rotate these 2 wheels consecutively. That means these 3 wheel pair or these 3 axle are actually grouped together, and these 3 axle also another group. So 2 group are there, and as I told 3 axle are there. So we write C hyphen C. I told if it is a group drive, so no need to use any subscript. If it is single motor drive, you have to use subscript. So I hope you cleared all about this example, this code thing. I think to add some general knowledge in this chapter, you should know that the completion of second 5-year program 1957, so total 216 route kilometer of Indian Railway are actually electrified. Okay, so we can say the first electrified route is a route between Rajkharswa to Dungoposi. The first electrified route is between Rajkharswa to Dungoposi. It comes under Southeastern Railway and it was developed in 1960. Then after in two consecutive routes actually electrified, the first one is Howrah to Bardhaman, which comes under East Coast Railway, and the second one is Madras Beach to Tamram, which comes under South Railway. And these two electrification take place in 1968, right? And after the electrification of track, Indian Railway loco manufacturer actually interested to design electrical vehicle or electrical locomotive. So the first electric locomotive, that is called the first electric locomotive in India, which is run over 1500 volt DC, that is called Lokmanya. It actually inaugurated or flag off 14th October 1961 by Jawaharlal Nehru. So these are all about the basic knowledge or general knowledge about electrification of track. I hope this is important for you.